Hi everyone, welcome back to the channel. In our previous videos of K-map, we already discussed about 2 variable, 3, 4 and even 5 variable K-maps. So now we will also discuss in that only essential prime implicants and prime implicants, how these are important and their importance on how to identify them carefully while grouping. Let's begin. So let's start with an example that why we need the prime implicants, essential prime implicants. So this example is basically I took from our previous video of 4 variable K-map. So if you observe, after doing all this according to the K-map rules only, we are going to have 4 groups. We can say 4 groups. So we can say that why these many groups are present. So yeah, these are very required for the minimization of the K-map. So the blue group is, we can reduce that blue group. So without blue group also we can cover all the ones. After reducing the blue group, we have left with only 3 groups. So the output equation would be that, looking like that. So F2 is A D bar plus BD plus AC. So that is the main use of identification of the reductant groups. So the blue group is also known as reductant group. So without using also, all ones can be grouped. So with the help of implicants, prime implicants and essential prime implicants, we can identify in each and every step of the formation of groups. So which group is necessary, which group is not necessary. So which are reductant groups and which are to be the final output minimized. So perfectly minimized or not can be implemented, can be checked with the help of essential prime implicants. So let's check how to minimize with the help of essential prime implicants. So before that, let's understand what is meant by implicant. So the main things that we are going to do is prime implicants, essential prime implicants. So implicant means the whole thing, the combined thing is known as implicant. So the basic thing is a single one or group of ones adjacent to each other can be combined, is called implicant. Or min terms or ones also. So basically we call ones as min terms or min terms as one in the K-map itself. For more understanding about implicant, let's take an example. So this is the example that you are seeing. So I have given in the SOP format, that is the F1 equation. So the same equation can be represented as the sigma notation also. Both of notations are same. So I have filled in the K-map also. You can observe I have highlighted each and every term. So the each and every term is also known as the min term or implicant. So you can observe there are total 6 min terms or 6 implicants in this. So those are the highlighted things that are known as implicants. Each and every min term is also known as implicant. Then now you might get a question. In K-map we have to aim for the larger groups and aim for the lowest groups, means least number of groups and largest groups. So we can map a group of 2 elements. Then why you are mapping a single element? So single element represents implicants. So these are known as groups. So we will see now what is meant by prime implicants. So the important things are prime implicants and essential prime implicants. Implicants means nothing but just the overall all terms. All terms means it's not just normal representation. So we don't need the implicants. We need only prime implicants, essential prime implicants. So I hope you know how to form the groups. So formation of groups involves only in the power of 2. So the 3-term grouping is not allowed in this. So for the 4-term formation is allowed, but the T-shaped is not allowed. The groups or shape of group formed should be only in square or rectangle type. So this term of forming as 4 in a group is not allowed. So let's start with the prime implicant. So our ultimate goal is to find essential prime implicant. So learning prime implicant is the first step. So let's see the definition once. A prime implicant is an implicant that's minimal. So that's minimal. You can't remove any more literals variables without making it no longer an implement. So you cannot. So by reading this definition, it might be confusion. So let's see with an examples. So if you look at the first example, so this is the first example. So the number of terms or number of ones in that is also known as the implicants. So now in this first example, we are going to find out what is prime implicants and essential prime implicants. So total we have 8 terms or 8 ones. So we can say that we have 8 implicants. But the prime implicants, if you observe, so just do normal mapping. So how the many terms or many possibilities of making groups according to the K-map rules is also known as prime implicants. So this is the first group that we can make of 4 elements side by side. According to the K-map rules only, we have followed the rule and formed a group of Karnaugh group. So the next biggest group in this is 4 element group. So that is highlighted in green color, 12, 13, 8 and 9. So that is also known as prime implicant. So for mapping the single element, we have to make the largest group. So that the largest group that can be formed there is the element of 4 elements. So that is also obeying the K-map rules. So that is also known as prime implicant. This is the last group that we can make in this K-map. So this is also known as prime implicant, because we, according to the K-map rules only, we have followed all the rules and we made that group. So these 4 groups are known as prime implicants. According to the K-map rules only, we have followed all these things. But if you observe the clear-cut thing in this, that is, if you observe green group, so green group is also known as reductant group, because without green group also, we can map all the ones in that. All the minterms we can able to cover. So let's see that. After removing the green group, so the groups will look like this. So the remaining groups are known as essential prime implicants. So if removing all the reductant groups, the remaining groups are very necessary for forming the groups or minimal output equation in Boolean algebra. So the minimal expression can be obtained with the help of only essential prime implicants. So I hope you understood what is meant by essential prime implicants. The groups that must be very necessary, very important for the formation or for minimization of the Boolean expression is known as essential prime implicants. So these are known as essential prime implicants. So the essential prime implicants, EPIs, are very important in minimizing our Boolean expression. So the target is to find essential prime implicants to minimize the finest output. So let's see a second example. So according to that, we have filled something random like this. So for this, we are going to find the implicants, essential prime implicants. So let's see, start. We already know the each term or each min term, the SOP, is also known as the implicant. So in this, we have total 8 terms or 8 ones. So that is, we call them as 8 implicants. Let's start making the prime implicants. So in the understanding of prime implicants, we know already we can make a group of 4 that. So this is one of the prime implicant, also known as Karnaugh grouping. So this is the next group that is highlighted in a green color, is also known as prime implicant. So the groups that are formed with the help of K-map rules are also known as prime implicants. The remaining 2 also can be mapped according to the K-map rules. For covering the last one, that is in the 5th position, we are going to have a largest group, that is group of 2 elements, that is 5 and 13. So that is also known as prime implicant. Now, as there is no reductant groups, means compulsory these 3 groups are very necessary for the formation of final output, because we have to cover all the ones. That's the necessary main point of doing K-map. So for the covering all ones, these 3 groups are main needed. Without these 3 groups, there is no, the output would be. So these 3 are also known as essential prime implicants. So we have 3 essential prime implicants. For your simple understanding, I have mentioned the groups, all groups, and I have take reductant groups. If reductant group is present, I have removed that. So after removing that, remaining groups are also known as essential prime implicants. So that's our one of the point. But let's see what is the actual thing that we are going to see in the formation of essential prime implicant groups. So let's see the definition once. So it is the prime implicants where at least one min term or one is not covered by another prime implicant. So let's understand this definition with help of some examples. So basically, essential prime implicants are also prime implicants, but at least one should not be covered with other prime implicants. So let's see that. So up to now we have discussed 2 examples. So in the 2 examples we have said about prime implicants, essential prime implicants. So let's understand with the actual definition also. Let's took the first example, that is if you consider the prime implicants. So these are the overall prime implicants. So the green group is reductant group. So we have already discussed about that. So according to the definition of actual essential prime implicants, so we are going to judge according to that. If we observe according to the essential prime implicant, the definition says at least one should not be covered with the prime implicant. So if you observe the blue box, so I have highlighted with a circle, that is in the 4th position, that is 1 I have highlighted. So basically the blue group highlighted 1, that is prime implicant. So that one is not covered with the any of the other prime implicants. So that group is also known as essential prime implicant. So if you consider the purple box, in that is also known as prime implicant. So 6th position and 14th position are highlighted in the ones are highlighted. So because these 2 are ones also not sharing any of the thing or the common thing with the other prime implicant. So this is also known as the essential prime implicant. So the purple box is also essential prime implicant. So the definition says at least one should be the next part or the remaining part, or should not overlap with the prime implicant of other group that present. So the blue group, the purple group are prime implicants and as well as essential prime implicants. If we observe the red group, so the 13th position is sharing boundary with other prime implicants. But let's observe the 9th group. So the 9th position means not group, 9th position. So the one that is there in the 9th position is not sharing with the prime implicant there. Is not sharing with the other prime implicant. So that is the at least one. So that is also the main thing. That is also the essential prime implicant. So the remaining group, the last group, that is the green box. So let's if you observe that everyone, each and everyone, if you observe fifth position is sharing, that is the green box itself is a prime implicant, but inside each position is sharing with other prime implicant. The fifth one is sharing with the fourth one, means the blue box. Seventh one is also sharing with the blue box and purple box. 51st one is sharing with the purple box. 13th one is sharing with the red box. The each and everyone is sharing with the other prime implicants. So that is not considered as essential prime implicants. So the because of not considering essential prime implicants, we can simply consider as reductant group, and we can reduce that. Simple as that. So we already discussed about that, but according to the definition, the actual definition, so after seeing any example, we can directly understand. So at least one is a part of other essential prime implicants or not. So how we have to, after following the K-map rules, is there any reductant group or not, we have to check according to that. So this is essential prime implicants. These are the remaining three groups are. We have understood the first example clearly. So let's see the second example also with the help of the actual definition. So these are the three things that we have got with the prime implicants, the actual groups that we can make with the help of the K-map rules. We have three prime implicants. So out of these three prime implicants, we have to check what is the essential prime implicant groups. So for that, first group that I am considering is highlighted in a corner groups, that is blue color. So I am highlighting, so any of the three things that is present in 0 to 10 can take as a circled one. So but I took in the 0th position. We can take any of the three because 8th one is already present in that green group. So I am taking any of these three that is present in the 0th position. So if you consider in the green box, we have two not participating in the other reductant groups. Not the reductant groups, other prime implicants. So if you consider in the 12th position and the 9th position is not participating in other prime implicants, so that is also the essential prime implicant. So if you also consider the purple box, so I have highlighted in the 5th position, so that is the one that not involving in other prime implicant boxes. So these are the three. These three are very important for the formation of the output equation. So that is the reason these three are again considered as essential prime implicants. So first we consider as prime implicants, we check the individuals. So at least one is a not part of other prime implicant. So if that, so we will be going to consider those three as essential prime implicants also. So in this example, we have three essential prime implicants. Let's see the next example. So in the next example, if you took like somewhat like this, so in this we have total 6 ones or the 6 min terms. So according to 6 min terms, we can also say that we have 6 implicants. So these are the 4 groups that we can make. So these 4 groups are known as prime implicants. So the group is blue, purple, green and the dark blue. These are the things. These are the 4 groups can be formed. If you see clearly in the prime implicants, so the 5th position, that is the one that is sharing in the purple box, the 5th position is sharing with the blue box. So the 13 is also sharing with the green box. So the purple box is a reductant group. So we can reduce that. So after reducing that, we have left with only 3 boxes or 3 cells or 3 groups we can say. So that is our the essential prime implicants. We can simply reduce or reductant group, that is purple color can be highlighted, that can be removed. So we can have 2 representation of output, that is the corner representation like that, the second representation. So the first representation, so we can simply 4 5, that is 13 9, that is 6 14. So as represented like that, so we can have the second representation also. So both are correct, both are the essential prime implicant boxes only. So we can represent in any of the manner. But remember, the finest group output would be containing only 3 essential prime implicant groups. As I mentioned in the starting of the video, we already discussed about the basics, that is 2 variable, 3 variable, 4 variable and 5 variable. So but in those videos we have discussed directly with the help of only essential prime implicants. So in this video we have understood, so what are prime implicants? Basically prime implicants are nothing but all the possible combinations that can be made with the help of the K-map rules. But with the help of K-map rules, if any reductant group that can be formed, that can be reduced with the help of essential prime implicants. So essential prime implicants are very important. So let's see one more example. So this is also one of the example that we took in the previous video. So after filling like that, we have that many min terms. So as there that many min terms, that many implicants also. Same number of min terms is equals to number of implicants. According to the K-map rules that we have followed in the previous video, as to that, so we have to took directive. So there is no reductant group in this. So we are directly following K-map rules and we are getting the groups, and we are going to have the final output as three groups as three output terms. So those three are known as prime implicants. Those three are also known as essential prime implicants. But as I mentioned earlier, the prime implicants can be any of the kind. So in the previous videos we have directly discussed the minimized one. So those are the minimized things, but we can have the prime implicants more. So if you observe this, so this is the same thing, that is the fourth example only, but we can have the more prime implicants. So those three, the remaining groups, the remaining three groups are also known as prime implicants, essential prime implicants also, but we can have the essential prime implicants only three, but the prime implicants can be more. So example for that is these two groups. So these two groups can also be grouped according to the K-map rules only, but these two groups are reductant groups. So according to that I have reduced that, I have not took that. So we can also form a group of C bar D, the horizontal row. So sorry, that is a vertical row. So we can have that group also, the four elements, the vertically, that is one present in the 1, 5, 13 and 9th position. So that group can also be possible. So we have took the minimized one. So according to the choices, this is the main representation or main usage of using the essential prime implicants and prime implicants, of reducing, of understanding which group has to be taken, which group has to be not taken in the output format. That's our choice, but the main thing has to be, remember, we should have only essential prime implicants. So this is another example that we have already saw in the previous video. So in this also we can see I have wrote directly there the essential prime implicants. So you can observe we can have prime implicants. So those three known as prime implicants, but we can have more prime implicants like 5, 7, 13, 15, 9, 11. But we have to choose the main things. So the prime implicants that can be converted as main prime essential prime implicants. With this, all these things, we can conclude some of the statements. So by seeing the Venn diagram, you can observe. So implicants are nothing but the individual terms or the min terms. So if 10 min terms are there, if 10 min terms are reduced to 5 min terms with the help of K-map, so those 5 terms or 5 groups are known as prime implicants. So in the 5 terms on prime implicants, so we have one reductant group. So after reducing that, we have left with only 4 prime implicants. So those 4 prime implicants are also known as essential prime implicants. So with these 4 only, we are covering all the ones in the K-map. So I hope you can understanding with the help of the K-map and with this Venn diagram also, how we can reduce the 10 terms to 4 terms with the help of these things. We can also pass some statement like all the essential prime implicants are prime implicants. I hope you understood the difference between prime implicant and essential prime implicant, and why we are only looking at the essential prime implicant for the output, cleared with the help of Venn diagram also. Thanks for watching up to now.